Okay, so we're going to look at absolute value equations. Now, first, let's just review what we mean by absolute value. If we see something like this, like let's suppose that we have a little vertical line here and we have the number 3 in there, and then close it off with another vertical line. Of course, we've learned in the past that that's just 3. Now, one of the ways you can look upon this is you can look upon this as the distance from 0. So here's 1, 2, 3. See, so 0. So the absolute value is of 3 is 3. Now, also we could say, well, what about negative 3? The absolute value of negative 3. Well, it's also 3, because what you're saying is, well, how far is negative 3 from 0? And you can see it's 3. See, 1, 2, 3 units. So what we note here is that the absolute value of negative 3 is equal to the absolute value of 3, and they're both equal 3. And in fact, you know, oftentimes we think of the absolute value as just making the positive of whatever's in there. So if we have the absolute value of negative 7, it's 7. Absolute value of 8 is 8. And of course, the absolute value of 0, well, that would be 0. Now, what we want to do is we want to look at problems like this. Let's suppose that we've got the absolute value of x equals, let's say 5. And we want to look at, well, what values for x will make that true? Now I'm gonna look at it graphically here. So let's suppose here's 0 and here's 1, 2, 3, 4, 5. Okay, so right here, if x equals 5, that's definitely a solution to that equation. But that's not the only solution. If we go over here, negative 1, negative 2, negative 3, negative 4, negative 5. This is also a solution. So you can see that this equation has two solutions, x equals negative 5 or x equals 5. Now, that's the way we're going to approach these absolute value equations. We're going to realize that whatever's in the absolute value could be the negative or the positive of what it is equal to. So let's just modify this a little bit, and let's suppose that x plus 1 equals 5. Okay? In other words, what we're saying here is that if we take this x plus 1, for what values for x will we just get a 5? Or, on the other hand, x plus 1 could equal negative 5. Because if x plus 1 equals negative 5, the absolute value of negative 5 would be 5 as well. So, in fact, this absolute value of x plus 1 equals 5, an absolute value, is two equations in one. So we have to solve both of these. So over here we get x equals 4. Over here we get x equals negative 6. See, we just solved both of these little equations. So there are two solutions. This is the way we deal with absolute value equations. So let's look at another one here. Let's suppose we've got 2x minus 5 equals, well, let's say 4. So immediately, the way we set out to solve these, we take the 2x minus 5 equals 4. That gives us one solution. Or, don't forget, the 2x minus 5 equals negative 4. So I add 5 to both sides. I'll do this equation first. And we get 2x equals 9. Then I divide by 2. And I get x equals 9 halves. Okay? So that's one solution. Then we come over here to the other one and say, okay, well, now I'm going to add 5 to both sides. And I get 2x equals 1. Then I divide by 2. And I get x equals 1 half. So our two solutions are 9 halves or 1 half. But always what we do is we make two equations out of it. So let's look at one. Let's look at this one. Let's suppose we've got 3x plus 1 minus 2 equals 7. Okay, and notice this is an absolute value. So what we have is we have two equations. Here's the first one. 3x plus 2 minus, or x plus 1, sorry. X plus 1 minus 2 equals 7. Okay, there's the first one. Or, come over here the other side, 3x plus 1 minus 2 equals negative 7. And notice the only difference in these two equations is, on the one hand, I'm equal to 7. The other hand, I'm equal to negative 7. So I just commenced to solving this. And remember, first thing I do is clear the parentheses. 3x plus 3. See, I had to get the x out of the parentheses so that I could solve. It was trapped in there, so I used my law of distributivity to liberate it. Okay, now I add the numbers on the left side of the equal sign, and I get 3x plus 1 equals 7. See? Okay, then subtract 1. 3x equals 6, and then divide by 3, and I get that x equals 2. Okay, so that's one solution. Now let's look over here at this other one. I've got 3x plus 3 minus 2 equals negative 7. So at the beginning, this, it's just like the other one. We add the numbers on the left-hand side. Now we want to isolate the x term, so I subtract 1. And I get 3x equals negative 8. Okay. Now divide by 3. And I get x equals negative 8/3. And that's my other solution. So I get two solutions. This is the way we approach all of these absolute value equations. Now, let's just take note of something here. Let's suppose that I have absolute value of x plus 1, let's say equals, or let's just make it simpler. Let's suppose we have this equation. The absolute value of x equals negative 1. Now, this is saying, what do you take the absolute value of and get a negative number? Well, nothing. So this one is no solution. So this is an example of an absolute value equation with no solution. It equals something negative. Now, let's look at this one. Let's suppose we have the absolute value of, let's say x plus 2 equals 0. Well, that would be the absolute value of x plus 2 equals 0. And we could say absolute value of x plus 2 equals negative 0. But this right here, it doesn't make any sense, negative 0. So if it equals the 0, we only have one equation to work with. So remember, with these absolute value equations, you set it equal to whatever is on the other side, just dropping the absolute value, or the opposite of what's on the other side. Now, let's look at another one here. Let's suppose we have 3 times the absolute value of 4 times x plus 2 minus 1. And let's suppose this is equal to, let's say 6. One of the things, you notice this 3 is on the absolute value, it's on the outside of all the absolute value. What I like to do is isolate the absolute value. In other words, just divide both sides by 3 before I go any further. And I get this. I get the absolute value of 4 times x plus 2 minus 1 equals 2. Then I break it up into my two equations. 4x plus 2 minus 1 equals 2, or 4x plus 2 minus 1 equals negative 2. And then I solve those two rascals right there. So when I do that, notice I get 4x plus 8 minus 1 equals 2, or 4x plus 7 equals 2. Subtract the 7, and I get 4x equals negative 5. And finally, divide by 4, I get x equals negative 5/4. Same thing over here for this one. I get 4x plus 8 minus 1 equals negative 2. 4x plus 7 equals negative 2. Subtract the 7, and I get 4x equals negative 9. Divide by 4, and I get x equals negative 9/4. So there are my two solutions, negative 5/4, negative 9/4. And that's the approach you take to solving absolute value equations.